Good morning, Cappuccino. Welcome to week 3, day 3. Today's April 1st, distance teaching and learning. So here's our warm-up. Sorry, it got kind of wordy. It didn't look so big when it was typed out, but it looks kind of a lot when you write it out by hand. Sorry about that. So if you just want to, while you're writing this down, you can just abbreviate stuff, apples, mean equals this, standard deviation equals that, okay? Don't worry about writing down all the words. You don't have to do that. All right, so notice it says it's normally distributed, okay? I want to give you a couple of hints. What proportion of the apples in the shipment are medium? Okay, the proportion that are medium, you can express that as a percent. And so when it asks for proportion, that's the same thing as asking for what's the probability that the apple will be medium, okay? So that's just a little tip. You can solve proportion problems the same way that you would solve probability problems. So the proportion is, you're going to express it as a percent. Oftentimes proportions are expressed as a fraction, but I want you to change it. I want you to actually write it as a percent because you're going to be using your calculator to get the answer. So it's the same as calculating the probability that it's going to be medium, okay? So just a little pro tip there. Proportion and probability are basically expressed the same way as a percent. It's the same question as asking what is the probability that apple in this shipment is medium. Okay, so once you find that, that's going to help you solve the next question. In a bag of 10 apples, what is the probability that there are at least 8 medium apples? Now, this should look kind of familiar. Look, we're picking 10, and I want 8 of them to be medium. So either they're medium or they're not medium. So you're picking these 10 apples, either they're medium or they're not medium. So this is a binomial distribution, okay? So we've got two things going on here, a normally distributed probability and then a binomial distributed probability. So we're going to use our two things that we've been learning recently to answer that question. All right, so those are your big hints for the day. And again, I'm going to take the first 5 people who get me the answer are going to get extra credit. All right, yesterday's. For those of you who didn't do it, it's time to do it. Here we go. So let me get some scratch paper because I don't know if I have enough room on here. All right, so the first problem, do I have a pencil handy? Yeah, we'll do it with red pen. Is this a valid probability distribution? So if you look back in your notes about a probability distribution, there's two things that have to be true. The probabilities they have to add up to exactly 1, and no single probability can be above 1 or less than 0. So we are going to set up a probability distribution. That's with a table. So we have our x values, which are going to be 1, 2, 3, and 4. Notice it doesn't go like ... or anything. It's just exactly those numbers. And then the probability is dictated by this function. So we're just going to substitute in 1 for x. So 1 squared is 1. 1 plus 1 is 2. 2 over 34. Whoops, 2 over 34. That would be the first probability. Then we'll do the next one. Substitute in 2. 2 squared is 4. 4 plus 1 is 5. So I get 5 over 34. So far, so good. See, they're both positive. They're not less than 0. And neither one of them is greater than 34. So we're looking okay. 3. 3 squared is 9. 9 plus 1 is 10. So 10 over 34. And then the last one, 4. 4 squared is 16. 16 plus 1 is 17. So 17 over 34. Okay, now all of these meet the definition of a probability. They're between 0 and 1, so that's good. Now let's add them together and see if they equal exactly 1. So 2 plus 5 is 7. 7 plus 10 is 17. 17 plus 17 is 34. So if I add these together, it does work. I get 34 over 34. So it meets the two rules of a probability distribution. Equals 1. The probabilities of this event all have to add up to 1. Okay, that's it. So that's what you had to show. You had to show that all of these are between 0 and 1, and all of these add up to 1. So there it is. Okay, so all are between 0 and 1. 0 and 1. Okay? All right. Next, given Given an event X that is normally distributed with a mean of 16 and a variance of 2.5 squared, find the probability that of the event being less than 20. All right, so this is a calculator problem. So I'm going to grab my calculator and let's clear that out. All right, so second vars, it says it's normally distributed, so we're going to use option 2. And it says, what is the lower limit? So when I'm setting these up, I kind of like to do it on a number line. I say, here's 20, and I'm talking about x is less than 20. That's that way. So I can see my upper boundary is 20, but my lower boundary is negative infinity. So I'm just going to put in a really big negative number. Okay, just something really negative. Okay, and my upper boundary is 20. My mean, we said, was 16. And my standard deviation is 2.5 because it's the square root of 2.5 squared, which would be 2.5. Enter, 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 and I get 0.945. Okay, 0.945. All right, now, if the value is 20, find its z-score. Okay, so my value is 20. I want to know what's the z-score of this guy here. Okay, so my z-score. By the way, I could have sketched this also. I could have sketched my normal distribution, which is a nice thing to be able to do. My mean was 16. My standard deviation is 2.5, so 16, 17, 18.5. And then this way, I would minus 2.5, so that would be 13.5. Okay, so my z-score here, my z would be 1. Here my z would be negative 1. 20 is going to be over here, so it's going to be more than 1. I know my z-score is going to be more than 1, but let's go ahead and use the formula. So from the notes, we had the formula that the z-score is equal to, oh shoot, I'm doing it right in my notebook. I meant to do it on here, so I have more room, but oh well, whatever. Is equal to x, the value of x minus the mean divided by the standard deviation. We want to know how many standard deviations is 20 away from the mean, 16. So I know that x is 20, the mean is 16, and I'm dividing by the standard deviation, which is 2.5. So that gives me 4 over 2.5. I'm going to go ahead and use my calculator for that. 4 divided by 2.5 gives me 1.6. So that's equal to 1.6. So my z-score is 1.6. All right, next question. Given that the z is normally distributed with a mean of 0 and a standard deviation of 1, find the probability that z is less than 1.6. Okay, that's a less than 1, so that's like this. So I know that 1.6 is going to be my upper bound. So let's go ahead and go to my calculator. So my lower bound is still a giant negative number. My upper bound is going to be 1.6. And my mean is going to be 0. And my standard deviation is going to be 1. Before I actually do this, I'm going to go ahead and sketch this out. I keep forgetting to sketch these out. Here's my normal distribution. It says the mean is 0. So right here, this is 0. Standard deviation is going to be 1. So this would be 1, and this would be negative 1. And 1.6 is going to be over here somewhere, okay? So just like this one, 20 was going to be over here somewhere, okay? And then we're looking for everything less than 20, okay? So same thing here, 1.6 is going to be over here somewhere, and so here's going to be like my 1.6. So I'm looking for the probability of all of this. Oh, looks kind of familiar, huh? Right. So let's go ahead and get that answer, and I get 0.945. Whoa! What just happened? I got the same answer again. Okay, so look what has happened. I took a situation that had a mean of 16 and a standard deviation of 2.5. I changed it to a z-score. See the 20, probability of 20? I figured out what's the z-score of 20. The z-score is 1.6. And then I found the probability of having a z-score of 1.6. Notice I even used the letter z. What's the probability that a z-score will be 1.6? Well, when you're talking about z-scores, the mean of z-scores is 0. okay, because z means what's the distance from the mean to the standard deviation. So if you're on the mean, the z-score is 0, so therefore the mean of z-scores is 0, and the standard deviation is 1. So this is our, what did we call it again? Our standard normal variable. This is the standard normal deviation, kind of like our unit circle, but for normal distributions. And notice when we changed the z-score for the x is less than 20, we changed it to in terms of z. Because I found the z-score of 20, and then I found the probability of having a z-score that's 1.6. It gives us the exact same answer, right? So that is kind of cool. So we're going to use that idea later on today when I give you your notes. All right, so that was yesterday's warm-up. Here's today's warm-up. Have at it. I'll be posting notes later this afternoon. I got to go help my son apply for student housing at CSU Long Beach. Go Sharks. All right, have a great day. Bye-bye.